Hi there. Welcome to the Garage Door Project ComponentTest walkthrough video series. This is the third and final part about the user interface that I built using M2T Caleb. In the previous videos, in part one, we had a look at the underlying hardware and how it was connected, the schematic and the wiring. And in part two, we had a look at the component classes that I've created to interface with that hardware on the Intel Galileo running Windows. So, if you haven't watched those videos, go do that. And now we'll get into looking at the user interface. When I started work on the Garage Door project, I chose a ST7565, which is a nice little 128 pixel by 64 pixel display. And so I went looking for some code to go drive that display. That code that I ended up picking was U8 Glib, which is a great little library, wealth of support across a variety of displays. And I was able to get that code up and running. I have a previous video on bringing up the U8 Glib and the experience that you got from moving from software to hardware SPI to that display. So you can have a look at those videos if you want to go back. When I looked at doing the user interface, I wanted to have a more traditional scrollable menu type user interface, rather than just simply having a bunch of buttons that toggled open closed or read distance or put stuff in. I wanted to set the distance that my wife's car was parked at. What I wanted to have was to have a UI be able to scroll through items back and forwards and render some interesting graphics based on that 128 by 64 pixel display. So fortunately, the author of U8 Glib also did a library called the M2T Caleb, which is the Mini Interactive Interface Toolkit library. And so I was able to grab that library, and it's designed to work with U8 Glib underneath it. So I grabbed that library, ported it across to Windows on the Intel Galileo as well, using Visual Studio 2013, and got it running and was able to build a test UI and confirm it all worked. And so I used M2T Caleb and U8 Glib as the graphical stack for my Garage Door project. And so today we're going to have a look and see how I used M2T Caleb. Now, you may have noticed, if you look back here on the U8 Glib, that this code.google.com is closing down and they're moving people to GitHub. So they've moved, the author moved U8 Glib, and I assume that he's going to move M2T Caleb across as well. And so at some point, you'll be able to get these libraries on GitHub, and I'll be able to take some changes and so on and integrate in. And so instead of having clones of these libraries on my GitHub here, I'll be able to get rid of these and just use the libraries that the author, Oleg Kraus, I think it is, or Ollie Kraus, has to actually drive these displays. And this is a phenomenal library. A ton of effort went into this. And you'll notice here, if you look at his GitHub page, that he has a new library, UC Glib, and it is designed for color displays as well. So I'm sure that's taken those the architecture and his learnings from the U8 Glib and applied it to UC Glib. So I hope at some point he'll grab M2T Caleb and move it over here too, and people will be able to continue to use that. So with that background, let's take a look at how I used M2T Caleb. If we go over to Visual Studio now and have a look at the source for the component test harness that I wrote for the Garage Door project, what you'll remember is that I have a set of libraries. I have a set of code broken down for the components, which are the hardware components in the system. I have a set of files like main and std.afx.h that are basically the core logic and the control of the Arduino experience and how you write a wiring application. And then what I have are these user interface files, which enable me to write or have all of the classes that are resolved to the user interface in a single location. Now, M2T Caleb utilizes or recommends a state model for building the user interface. And so that's what I did, is I sat down and I created a state model. And so the first thing that I do is I start and display the main menu. Then I wait for some interaction. Now that interaction is going to be a request to display the distance, display the door state, or to toggle the door open closed. Now on each of those actions, I will go to a different state. So if I want to display the door state, for example, I'll come up here and I'll move to the display door state, and I set my root to be the door state view, so it shows the list, it shows the UI for the door state, and then I print that state, and then I wait for the response from the door or from the user. And what I'll do is I'll every so often go off and I will check the door state, and I'll check to see if it's closed, open, or traveling, and then I'll refresh the screen. When the user presses the door state OK, I'll set the root of what I'm displaying back here to the main list, and we'll have the wait again. And I do the same for the distance, and then I do the same for open, close, door. And you can see how you flow through the various states. Now, it was a little bit confusing, and I didn't want to bring a line back here for this guy and then a line all the way back here as well. So the basic path back you can see here through open, close, door, where I'll come in, I'll pulse the reel, and I'll go back to the main diagram. So that's the basic state diagram. So let's have a look at what that means in code. Now, back here in main, you can see that I include a user interface header file. And this user interface header file is where I include all of the definitions and state required for me to run my user interface. So the first thing that I'm going to do is declare the UI functions that M2T Caleb will tie to the buttons. So when a button's pushed, what it will do is it'll actually go and call these individual functions as part of the interface toolkit. Then once I've got those, the next things that I'm going to want to go do is check my state and run my state machine. So I'm going to have a state machine implementation, and I'm going to have various states in the state machine that will enable me to go and display the main menu, wait on the main menu, and so on. And my state machine knows how to jump back and forwards. Now I can get to defining how all of my UI looks. So the basic way M2T Caleb works is that it has a set of elements. Those elements form part of a list that contains all the elements that may appear on the display. And then you take that list and you pass it to effectively a rendering list that says, go through the elements that were in the first list and then position them in this particular way. So let's take a look at how I used two of those. That's the XY list and the V list, and the various some of the various UI elements in my user interface. So the first thing that you see here, and I'll give you in the upper right hand corner a little video that shows the UI experience. The first one I have is my splash screen. It's a fairly common thing that people have in applications. While my system boots up and it goes through and instantiates all the controls and so on, what it's going to do is display this screen. And that screen consists of a label and an XBM bitmap. And I'm taking those two elements, and you can see here is the label, and I define the element, and then I have the label text, and I take that label and I take the XBM bitmap and I add it to this list, which is that controlled set, that list of things. And then I take that list and then I tell it that I want it to render in an XY case. And how I tell it where on the screen I want it to render is I use X0, Y0, and that would enable me to say that I want the XY to be a given value. In this case, as you saw in the image, it's just a very simple layout. I could have moved things around or so on. So that's the basic model and what I did in my startup screen. So let's take a look at some of the other screens, and you can see that, that flow go through. So here's the main test UI. I have 3 buttons, and I present that as a vertical list. And so that's a list that I can scroll up and down in, and then when I pick one that I like, I can click OK. And when I click OK on a particular element, what happens is that the element will call the function. And you remember those functions from a little bit further up in the code where we had these different types of functions here. What I've got is display distance, display door state, and open close here. Fairly straightforward. Similarly for the distance test, what I've got here is I've got now in distance test, I've got 2 lists because M2T Caleb is a hierarchical system. So the first list that I have is a label, and then this label pointer type. And the label pointer type enables me to say that this particular label is going to come from a string in memory or some value in memory. What that means is that while the picture loop is going through and continually rewriting the screen, I can, in another part of my code, update the string, and the next time that it's written, it will have the new value written to it. So I don't have to go and iterate to the UI and throw away UI elements and then update them and so on. Now I'm going to take that list, and because that list is distance and then the value, I'm going to have that render in a horizontal sense. I also want to have a button which lets me go back. Those 2 items go into the list, and then I want those rendered vertically. And so this model of composing your user interface is pretty straightforward, and it gives you an awesome amount of power, and that's inherent in the M2T Caleb code. So we have a look at the door state test. It's a similar approach that I've taken. I have the label, I have a label pointer, and then I take that, add that to a list, and then I present that in a horizontal format, and then I add a button to it, add that to the list, and I want that presented vertically. So it's pretty straightforward in how you define each of the screens that you want to go and appear. Now, when I move back and forwards to these things, I'm going to be utilizing the state machine. So let's go and take a look at that. So here's the userinterface.cpp file that implements the various items and functions that I have. So let's have a look at the state machine. The state machine is pretty simple. I start off, I have a value, I do a switch on that value, I check to see to do what I want to do, and then I tell the machine what next state. So in the case that I'm displaying the main menu, I'm going to set the root to be the element for that main menu. If we go back here, you'll see that the main menu element was this EL main vlist. And I set that root, and then I said the next state is going to be wait for main menu again. So I come in here, and now I'm just going to keep staying in that state up until something takes me out of that state. So let's have a look at that. If you remember back here, I have 3 buttons in that main UI. So the first button that I might hit would be, say, open, close door. So let's have a look at that. When I go and hit open, close door, I'm going to call the function open, close door. And if we come back here and expand this function, you can see that basically all I'm doing is when I call that function, I'm saying tell the state machine that it's going to be in open, close door state. So now it will actually go into the switch case and it will fall down to the open, close door, where I pulse the relay and then I tell the state machine where I want to be. Now, because I'm not rendering any additional UI, I can just jump straight back to here, and then I can go to wait again. Now, if I do that same thing to display distance, I'm going to call, FN display distance. And so if I come up here and have a look at display distance, I'm going to set the state to distance display. And first thing I do is I now tell it that I want the next route. And that route was what I defined up here with the distance vlist. So I set that, and then I say I'm now in wait for distance. Now, while I'm in wait for distance, I check to see how long it's been since my last check for the distance, because I don't want to be driving the sensor too fast, because remember I have a little delay in the sensor. So I'm going to wait for that. When it's correct, then I'm going to go into the state of getting the distance. So I format my string, I read the sensor, I set the next time that I'm going to check to be another second in the future, and then I tell it I want to wait on the distance. So I come back here, and now I sit back here again. Now that same model is applied when I click OK. When I click OK on that button, what I'm doing is setting back to display main menu, because remember, I've overwritten the display. So now I'm going to come back, and I'm going to set display main menu. I'm going to set the actual menu again. I'm going to tell it go back to the main vlist, then I'm going to wait on it. And that's the same model that I take for all the other items, whether I'm getting the door state, whether I'm displaying that while I wait for that door state. And so you can see the way the state machine wanders through the code. So that's pretty much it. Doing the user interface work inside of M2T Caleb and in this component harness is pretty straightforward, and gives you what you can see is that the start of a fairly rich and fairly easily to use user interface. So hopefully you found this interesting, and you be able to go and utilize some of this in building your own apps. Everything that I've shown you here applies equally to Windows on the Intel Galileo as it does to utilizing an Arduino. And hopefully in the future we'll be able to look and see how we can apply this in using Windows 10 IoT Core on top of a Raspberry Pi 2. Thanks.